My name is Mariam Reda, and I work under the Detroit Trauma Project at Wayne State School of Medicine. Our team works on the Critical Periods in Brain Development study, which studies trauma in children as they transition to adolescence prospectively and retrospectively, as well as focusing on the biomarkers of how trauma and stress affect development. Our study consisted of 40 9-year-old children living in Southeast Michigan, mostly from Detroit. We used the Violence Exposure Scale for Children Revised to measure lifetime violence exposure, and Fear Potentiated Startle to look at specific biomarkers. A frequently used psychophysiological measure of conditioned fear is Fear Potentiated Startle, which is the relative increase in the magnitude of the acoustic startle reflex in the presence of a previously neutral cue that is newly paired with an aversive cue. During the paradigm, participants undergo 2 learning phases. First, fear acquisition is where they learn to distinguish cues based on the presence of an aversive air blast to the larynx. For instance, a blue square is presented on a computer screen, followed by a loud startle noise 6 seconds later and the air blast 0.5 seconds afterwards. Participants learn that this blue square predicts this unconditioned stimulus. Trials with the purple triangle are CS- trials, during which participants learn that there is no air blast associated. Next, our fear extinction phase focuses on safety learning. Participants see the same CS plus and CS minus stimuli as before, but no air blasts are administered. By the end of the phase, participants are expected to learn safety, which overrides their initial fear learning. Participants are also presented with noise alone trials to measure their baseline startle to noise without visual cues. Fear potentiated startle was assessed via electromyographic recordings of the right orbicularis oculi muscle during differential fear conditioning and extinction. On the left, you can see how the eye blink responses are recorded and how they come directly after the sound probes. While studies have shown an association between early life adversity, such as traumatic experiences and fear potentiated startle, the developmental trajectory of this relationship is less understood. We know that fear conditioning paradigms have shown that fear potentiated startle is a common biomarker of anxiety disorders. Furthermore, due to the fact that there is increased risk for anxiety and depression in females during adolescence, and women abused during middle childhood show increased HPA reactivity to psychosocial stressors. Our objective is to characterize sex differences in the association between fear learning and violence exposure during development. Here we see successful fear learning in our participants. The top graph presents difference scores between the CS plus cue and noise alone in blue, as well as the CS minus cue and noise alone in red. We can see that participants are showing fear learning during acquisition, as evidenced by their increasing fear potentiated startle to the CS plus cue. Furthermore, in the bottom, we see that during late acquisition, participants showed a significant difference in fear potentiated startle to the CS plus compared to the CS minus cue. Safety learning is also evidenced in this sample. Again, we see the difference scores for each type of stimulus minus noise alone. A repeated measures ANOVA showed a significant difference of fear potentiated startle across extinction, where overall fear potentiated startle decreased significantly from the beginning to end of the paradigm. During the final block of extinction, there are no significant differences in fear potentiated startle when comparing CS plus and CS minus trials. When looking at overall fear potentiated startle to the CS plus and CS minus trials during late extinction, during which participants are demonstrating safety learning, there's a main effect of violence exposure and an interaction between violence exposure and sex. Here we can see that individuals with low violence exposure are demonstrating on average greater fear potentiated startle to both cues compared to individuals with high violence exposure. To better understand this interaction, we performed independent sample t-tests that confirm these differences. We can see here that there are significant sex differences to the CS plus and CS minus trials during late extinction. When we break this down by sex, we can see that females with higher violence exposure demonstrated lower fear potentiated startle to the CS plus cue compared to females with lower violence exposure. So, among females in this sample, higher violence exposure had a negative association with the acoustic startle reflex and evidently showing better extinction. This may be due to potential increases in hypervigilance among individuals with greater experiences of violence, where they are paying attention to the task more than their peers with lower experiences of violence. Our results suggest that differences in childhood exposure to adversity, specifically violence exposure, may be associated with differential fear learning. Because boys did not show the same patterns as girls in fear-potentiated startle, these results suggest a sex difference in the association between type of trauma exposure and safety learning. Ascertaining the neurobiological correlates of this adversity is critical to understanding both how trauma-related psychopathology manifests during middle childhood and whether there are certain predispositions to later diagnoses. By understanding these potential sex differences, we can build upon this knowledge to help map developmental trajectories in the field of trauma and childhood adversity. Here's some more information on the critical period study in our team at the Detroit Trauma Project.